Welcome back to Cybersecurity Insights. I'm Josh Mayfield with Absolute. With me today is Absolute's Chief Technology Officer, Nicko Van Sumeren. Thank you for joining me today.
It's a pleasure to be here.
You have some interesting history and some research that you've performed over your career. And today we want to talk a little bit about how organizations can become more resilient, sort of a theme and an important part for your research and the work that you're doing in steering technologies. But just tell us a little bit more about your passions and why you think resilience is so key.
I've been building enterprise security technology for 25 or so years, and over the years, I've just been watching people build more and more tools and add more and more layers of security into their systems, and yet we're still seeing so many vulnerabilities, so many breaches. And so one of my strong areas of interest is how do we build a more resilient security stack? How do we deal with our chronic failure in this? So when I look at a lot of the advancements that have been happening in technology for machine learning and big data, they seem like they really need to be used to the advantage of making a more resilient system. And that's one of the reasons why I'm really passionate about what we're doing at Absolute.
Okay, and another thing too, you and I have talked about this off camera in the past, but it seems as though there's this acknowledgement. You have the kill chain, you have zero trust, you have different frameworks, you have the analyst groups out there talking about all manner of different things. It's as though the industry has said, bad things are going to happen, but try to bounce back. What part does analytics play into that? So
I think that, as you say, when people have been talking about the failure of security at an analytical level for some time, but the vendors haven't really been engaging in that for the most part. We mostly see this from the analysts. We see people talking about kill chain that's been around for years, and it's all about how we've got many points in the chain where we can attempt to stop the bad guys. But that's basically a recognition that some of those failures, some of those controls are going to fail, so we're going to have to catch them later down the line. We've been seeing Forrester talking about zero trust as a way to do the data-centric protection because they think that the perimeter-centric is going to fail, and they think most of the other sections are going to fail. But we can't really build a resilient system unless we actually understand when systems fail and where they fail, because those are the only ways that we can fix those issues before the next one comes along. If we lose all of our layers of protection, then the bad guys will get through. So we've got to be able to remediate these failures. It's not just enough to say, oh, well, things fail, we're going to deal with it. We've actually got to work out how do we know when to deal with it and how do we know how to deal with it. And that's why being able to get visibility into the actions and events happening on the endpoints and then analyze those, that's why it's really important.
And everyone talks about the skills gap. And at the same time, you have a lot of vendors out there touting the trumpeted benefits of AI, ML, machine learning. And a lot of it is a paper tiger. A lot of it is just not real. It's a lot of graphic interfaces and pretty charts. But at what point can we compress that skills gap by recruiting the machines to help us?
Well, I think, you say paper tiger, I think that there's a really interesting analogy about machine learning. It's sort of like teenage sex, because everybody's talking about it, but nobody's really quite sure how to do it. And they're all sure that everybody else is doing it, so they pretend that they're doing it. But at the end of the day, very few people are doing this properly. Machine learning is statistics. It's statistics on lots of data. It's essentially about finding patterns in what's happening and then finding outliers that don't fit that pattern, trying to understand what makes those outliers distinctive and better ways to detect them more quickly. And then potentially looking at how humans have responded to those outliers in the past and proactively proposing doing the same thing when we detect similar looking outliers in the future. That's really what most machine learning and most things that get passed off as artificial intelligence are all about.
Tell me more about that, because we've talked about this again off camera. There's a strong distinction between machine learning and artificial intelligence. What are your working definitions, and what do you think is a respectable way to present that? Well, an honest way to put that forward.
If you're pitching it to a VC, it's artificial intelligence. If you're trying to hire the engineers, then it's machine learning. And when you're actually doing it, it's linear regression.
Spot on.
I think that what distinguishes machine learning from artificial intelligence, I think it doesn't really qualify as true AI until you can draw inferences that you've collected from one domain and start transferring them into another domain. That's when we start to get intelligence. For the most part, though, we don't actually need that. You were mentioning the skills gap. There's, depending on whom you are, somewhere between 500,000 and 3 million vacant jobs in cybersecurity, and there aren't people to fill them. There are plenty of people there working hard on solving cybersecurity problems, but they need leverage, they need magnification. If we can take the behaviors of those people and the data that they've acted on in the past and train a machine using machine learning to identify those patterns and those behaviors and put them together, that doesn't require domain transfer of knowledge. That requires machine learning. In fact, in most cases, it probably just requires a little bit of statistics. And when we do that, we get to magnify the capabilities of that core set of people that we do have available to help fill that skills gap.
And that makes a lot of sense, and it's more of an economically efficient way of doing things. And speaking of economics and the connection with statistics, what are the places to point the machines? What are the different behaviors, the different actions a human takes? Where should we look for signal, because it's greater signal among many signals?
We often don't know in advance what signals we want to look at. It would just be statistics if we already knew what signals we were looking at. So sort of what distinguishes statistics from machine learning is machines are supposed to be able to work out the signals that we should be looking at. But to do that, we have to collect a lot of signals because we don't actually know which ones we're going to care about in the future. What's important is that means we have to have the wherewithal to sort of reach into a device and pull out a lot of signals, collect a lot of data. People have been talking for a while about big data, but at the end of the day, this is about continuously collecting as much information as we can practically and efficiently collect and store. At Absolute, we have accumulated over the decades that we've been in business, over the millions of endpoints that we've been involved in managing. We've collected over 1 petabyte of data. That's 1 million billion bytes of data that are sitting there waiting for us to analyze. And when we've got that sort of volume of definitely big data, we now have the wherewithal to sift through that and look for the signals that we needed. At the end of the day, most of this is going to be coming from the software inventories, the hardware inventories, the signals about load on the system, the signals about behavior of the users, finding what's a pattern and what's an outlier. And we don't yet know what the right signals are, and that's why we want to be able to collect as much as possible.
And there's, of course, a lot of heterogeneity and all this. It's almost like a stochastic system, like weather. Time zero only goes forward one direction. And so if you were talking to an enterprise and you were telling them, these are the sorts of things you ought to be collecting, because although they may seem tried and mundane, they actually yield, when combined together, they actually yield a lot of signal and can help you avoid exposures before they become exploits?
There's a lot of stuff that we can do which is pretty straightforward. Like when we collect a software inventory, really detailed information about versioning is critical. We know that not only do the majority of attacks originate at an endpoint, but that many of the pathways in, as many as 70%, are through pathways which there's a patch available to fix that hole, but it wasn't properly applied. So being able to very accurately understand what versions people are running is critical. But also understanding things like what is the CPU and memory load. We might see, or the network traffic load. Sudden changes in the flow of data over the network might be an indication of exfiltration. So these indicators of compromise are things that people have been looking at for a lot of the network analytics tools, a lot of the behavioral analytics tools that are out there already. We want to, absolute, understand these not just from a security standpoint, but remember that people use us for a lot of security posture, but they also use us for a lot of very straightforward and very important IT management. And so understanding users in this cohort, the sales guys, they want the fancy laptop, but actually all they really need is email and a web browser, maybe PowerPoint. Whereas the person sitting in the back office running business intelligence has this tiny little machine, and actually the load that they're doing to build out these major BI dashboards is a huge burden on the machine. Those sorts of bits of analytics aren't necessarily about security, but they're still critical to getting IT's job done. So load, configuration, software configuration, performance information, who is using the device, where are they using it, how are they connecting, how are they traveling? All of these things are variables that we can put into the equations to draw insights.
Last question, I'm gonna turn to the controls themselves, typically in the form of, again, controls, settings, and those agents. Now, when it comes to agent behavior and how their interplay is, that's a tough nut to crack, because a lot of the telemetry and the information about that agent's health and its capabilities and what it's currently doing, is it performing at its best? Some of that is isolated for that particular AV or encryption or client management, patch managements, and so forth. How can one distill the behavior and understand how those are working with each other and if they're becoming problematic?
Well, when we collect information about different agents and about different pieces of software, we collect each of them in the context of the device that they're installed on. And as long as you've got a common key, it allows you to bring data from various disparate sorts. And there are many data analytics tools available for doing these sorts of things. But at the end of the day, as long as you've got a common key, which allows you to thread timeline information that's happening on a particular asynchronous schedule for machine X, and software inventory collected once a day for machine X, and hardware inventory, which hardly ever changes, for machine X, and user access for particular users and how they're authenticating for machine X. We tie them all to a common point, and now we can start to do interesting analytics on that machine, and then on this machine, and this machine, and this machine. Start to build out that big picture, which draws together lots of different disparate sorts of data which come in different timelines and different scales. But as long as they have that common point across our entire estate of machine X, machine Y, machine Z, now we get to build out a set of patterns which will allow us to draw those insights that we need.
I do want to ask one more question. Learned a lot here. Thank you for the visionary aspect of the pushing the envelope of the possible and the potential of what we can do. But if I were a chief security officer or CIO of an organization, 1,000 employees, not necessarily Fortune 500 or anything, but I'm doing the best I can, and I'm believing everything you're saying, and I say, Nicko, I got it, but what do I do now? What would you give them?
Well, I mean, of course, I'd tell them to buy Absolute software. But, no, but seriously, I think that the big struggle for a lot of organizations, they've gone to the conferences, they've seen the sales pitches, and they've bought solution X, solution Y, solution Z. They've layered on. They've got a dozen different agents installed on the endpoint. But we know that each of these controls, they get deconfigured, they get deinstalled, and often you don't know what you don't know. And so having just a single source of truth with the persistence that it will always be able to draw that data from the endpoint, no matter what the user does. That, I think, is the crucial piece that we hope we can add to people's organizations to give them the consistency and completeness of the data set so that they can then make really informed decisions about what value am I really getting from these tools, and how reliable are they, and am I actually getting to improve my security posture by having them.
So I want to thank my guest, Nicko Van Summeren, CTO of Absolute Software. Thank you again for being here today.
Thank you very much.